I was trying to decide what to do for an extra credit opportunity, and I figured that I would go ahead and give extra credit to anyone who watched this video, because it's just going to kind of give a preview of what we're going to talk about this week in class. So the next chapter in our book is discussing thermochemistry. And whoever watches this video and learns the concepts and can show me her notes, I'll figure out some extra credit to give her. But basically, the word thermo really is just a fancy word for heat. And when we say thermochemistry, what we're saying is we're dealing with the branch of chemistry that studies energy changes in physical and chemical reactions or processes. And again, the reason why I say energy changes is because heat is just one form of energy that we know of. So I wanted to go ahead and get started just by defining something. It's a term that you definitely will need for your AP chemistry exam. And for some reason, sometimes it confuses students, but really if you think about it, it makes sense. The word is called state functions. And for those of you who are working on your SAT English, you know that state is just like a fancy word for condition, right? Okay, so basically what I mean are there are certain, let's say I have a chemical reaction. Okay, I'm going to put it in a box here. So I have A plus B, and I'm going to put a double arrow A, B. Okay? We've already looked at what the double arrow means, and we've talked about it really briefly, but now I want to go into it in more detail. This double arrow, we talked about how it's a reversible reaction. The reaction goes both ways, but what I want you to think of in your mind is if I were to dump whatever A is into a beaker, let's say, okay, and then I were to dump B into that beaker, what's going to happen at first is, you know, A and B are going to start combining to make my product. They're going to keep making AB, 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 till it gets to a point where there's too much AB and suddenly the reaction is going to reverse, okay? And some of this AB is going to dissociate back into A plus B. So that's why we said we could write the reaction this way as well. Okay? So that's the first thing I want you to keep in mind. What that means is when you see this reversible, when you see this double arrow for a reversible reaction, I don't just mean that the reaction can go both ways. I mean that at any point in time, if I were to, you know, look through a microscope at what's going on in this beaker, what I would see is I would see this reaction taking place and this reaction taking place, okay? So basically, A plus B is constantly combining to make AB, and at the same time, molecules of AB are constantly dissociating into A plus B. And actually, at some point in time, it'll happen, these two reactions will happen at the same rate, like at the same speed. So if I were to just look at my solution, I wouldn't see anything changing. It doesn't look like there's any reaction taking place, but in reality there are two reactions taking place, as notated by this double arrow. There's this top reaction and the bottom reaction, but because they're reacting, both the opposite reactions are happening at the same rate, it doesn't look like it's anything. And when it gets to this state, when reactions, every single time you see a double arrow, that means that it's going to get to this state. That's going to happen. And we call those equilibrium. We say that now the reaction has reached can I spell equilibrium? Okay, there we go. That the reaction has reached equilibrium, okay? So why did I say all this, and what does it have to do with the word that you need to learn, state functions? And why did I say that state is a fancy word for condition? Basically, when I have reactions that reach equilibrium, okay, there are certain properties that I can measure, okay? They are macroscopic properties, all right? And those properties help me to describe the state of that system, okay? So I'm going to repeat what I said. A state function, it's really just a set of properties, and they're macroscopic properties, okay? It's not something I have to look at a microscope to figure out. These properties will help me to describe this system that is currently in a state of equilibrium. Once this system hits equilibrium, now I've got these state function, these properties, and you're going to have to know what is a state function and what are the state functions that you need to know, okay? So I had A plus B, and it reached equilibrium. Okay. The state functions that you need to know for your AP exam are temperature. This is one way to describe the system, right? And actually, you know what this is? I'm just going to put a big T. Pressure. I'm going to put a big P. Volume. Density. Internal energy, the energy inside the system, and there are many different letters. I'm just going to use the letter U. I believe that's the letter used on your AP exam. And then there's a few terms that we don't know yet at all. One, and we're going to be working with these terms this week. One is called enthalpy, which is the letter H. One is called entropy, which is the letter S, and the other is Gibbs free energy, which is G. So these we're going to be working on this week. And these you should already know. So, what is special about a state function? Because these are all state functions, okay? What is special about these state functions, the reason why we call it state, is because all of them, there is a relationship between all of them when the system, and only when the system is in equilibrium. So only when system is in equilibrium. Meaning, I can no longer see it changing. Remember how we talked about if I were to actually look at the beaker, if I were to actually look at this reaction in a beaker, okay, I wouldn't be able to see anything happening because the system has reached equilibrium, meaning that the forward reaction is happening at the same rate of the reverse reaction. Therefore, I can't tell anything special is going on. The system is in equilibrium, and there will be a specific temperature, pressure, volume, density, enthalpy, entropy, Gibbs free energy, and internal energy with which I can describe the system, okay? So again, at equilibrium, there are state functions that I can use to describe this system. That's really, really, really important to get down. And should I change one of these variables, let's say that I change the temperature, okay? The system will no longer be in equilibrium. The system is not going to be in equilibrium anymore. Something's going to happen. These other variables will be affected. So one state function is affected. You know, if the equilibrium changes, one will affect the other. That's the other thing you need to know about state functions. And the last thing you need to know about state functions is we're referring to this system at a specific state or at a specific time. At a specific, I just spelled that wrong. Okay? We're referring to its condition at a very specific time. So none of these variables help tell me anything about how the system got to where it is. None of the state functions do not tell me how did this system get here. The only thing it does is just describe the system when it's in equilibrium. That's probably the most important thing for you to remember this week. A state function is there are many state functions, but what it is it's a variable, or it's a descriptive way that I can explain what a system is like in equilibrium. I can describe the system at equilibrium, but I can't use them to figure out the process of how the reaction got to equilibrium, okay? So the temperature tells me nothing about how long it took for, to reach equilibrium. For example, And I want to say more, but I think I'm going to end it there. If you can remember this, you'll be good to go. So again, this is your extra credit. Just make sure to show me something or make a comment on the blog or something just to demonstrate that you actually have a clue about what we're talking about. You watched the video, you did your work, and good luck. Bye.